Okay, here is a team project for EE5135, and our team member is Jiang Yixuan and Yang Hao, and I'm Yang Hao. I'm doing this presentation. Okay, the team topic is about 5G applications and development in IoT. Okay, the first part is about introduction. With the rapid development of technology, the interest in 5G technology has reached an all-time high. 5G technology has made great breakthroughs in interpersonal communication, enabling efficient communication not only between people, but also between people and between things and things. One of the most notable features is its very high transmission rate. According to statistics, the transmission rate of 5G can reach 10 Gbps, compared to the transmission rate of 4G technology, which is only 1% of 5G. In terms of storage capacity, 5G is up to 1,000 times that of 4G. This provides a solid foundation for the widespread application of 5G in areas such as smart home and IoT, and also supports the simultaneous online connection of multiple IoT devices, thus promoting the development and popularization of IoT technology. In addition to applications in smart home and IoT, 5G technology also shows significant application prospects in areas such as smart cities, telematics, autonomous driving, and smart manufacturing. The high-speed transmission and low latency characteristics of 5G technology provide strong support for the development of smart cities. At the same time, there is also a huge demand for 5G technology in areas such as automotive, internet, autonomous driving, and smart manufacturing, which all require advanced information technology to achieve efficient communication and management. And 5G technology is one of the key technologies that can meet these needs. And here are some other characteristics of 5G technology. As a new generation of communication technology, 5G presents a trend of software-based and intelligent network structure. This means that 5G is not only a technology upgrade, but also a change in network architecture and concept. 5G also presents a cloud trend, which is reflected in several aspects. The first is cloudization of baseband processing capability. Next is the cloudization of mobile edge content and computing. In addition, there is a terminal cloudification, which is the deep integration of terminal equipment and cloud service, enabling terminal equipment to make full use of cloud resources to achieve more powerful and intelligent functions. At the same time, 5G is also a generation of cellular structural changes compared to previous communication technologies based on traditional cellular systems. 5G presents a more flexible and diverse cellular structure. The second part is about key technologies. The extremely demanding nature of 5G applications requires a revolutionary architecture for 5G networks, and several techniques have been proposed for integration with radio access networks to best serve the needs of customers. These techniques include flexible framing techniques, optimized OFDM-based waveforms, and multiple access techniques. These techniques are described in detail below. The first is about the frame technology. It allows the network to dynamically adapt the frame structure to different types of data transmission based on demand. The network can make intelligent decisions based on real-time traffic conditions, optimize bandwidth utilization, and ensure timely and reliable data transmission. The second is about multiple access technology. Multiple access technology allows multiple users to communicate simultaneously in the same frequency band. The application of this technology enables 5G networks to support more users and devices to connect, achieving wider coverage and faster data transmission speeds. Third one is about OFDM technology. Um, Another key technique is OFDM-based waveform optimization. By optimizing OFDM waveforms, it's possible to improve spectral efficiency and data rates while reducing power consumption and interference levels. This optimization enables 5G networks to better cope with high density and high rate data transmission, thus meeting the growing demand for mobile communications. Uh, also, orthogonal frequencies division multiplexing technology plays a vital role in 5G. Its advantage lies in its ability to effectively overcome frequency, selective fading, and narrowband interference while improving spectral efficiency and data transmission rate. In 5G networks, OFDM enables a variety of enhancements, such as improving multi-user transmission efficiency and creating single-carrier OFDM waves. The application of these functions enables the network to better adapt to different communication environments and application scenarios, thus providing better communication service. The basic principle of OFDM is to encode high-speed information data and implement it by assigning it to unparalleled orthogonal carriers. OFDM is insensitive to multiplies delay extension. OFDM employs the frequency domain coding and interleveling, leaving to create a connection between dispersed and parallel data. Unlike FDM frequency division multiplexing in the past, an OFDM receiver is actually a set of demodulator implemented by FFT, which is fast Fourier transform. OFDM uses a coordinated working method of power control and adaptive modulation. A balance exists between power control and adaptive modulation to ensure optimal transmission performance under different channel conditions. In an OFDM system, the functional block diagram is shown below. At the transmitter side, the serial data stream is first encoded, modulated, and several parallel converted. Then it goes through an uh, arithmetic unit, i.e. IFFT conversion. A guard interval is added, and finally it is converted to an analog signal by DRA and sent to the channel for transmission. At the receiving end, the analog OFDM signal received by the channel is converted to a serial digital signal by AD conversion. Then the protection interval is removed and the FFT operation is performed by the arithmetic unit. After several to several conversion and decoding, the original source signal can be recovered. Okay, the last one is about the self-contained integrate subframes. Self-contained integrated subframes are another key technology in 5G. By integrating data transmission and acknowledgement in a single subframe, the latency of communication can be significantly reduced, thus enhancing the user experience. TDD, time division duplex, is a full duplex communication technology used in mobile communication systems. It's capable of temporally differentiating wireless channels and performing both downlink and uplink operations during the frame cycle. In self-contained integrated subframes, the data transmission from the network to the device and the acknowledgement signals sent back by the device are done within the same subframe with 5G NR standalone integrated subframe. Each transmission time interval can be handled modularly. The graphical representation of the TDD download subframe shown here shows the data being downloaded and then passing through the protection interval and then moving to the acknowledgement phrase with the uplink. Since the use of TDD reduces the level of delay, the baseband system is able to meet increased user throughput requirements to support high data rate applications. Okay, the third part is about 5G in the Internet of Things. The widespread deployment of Internet of Things applications is not only increasing the demand on the underlying environments and infrastructures, but also placing greater demands on them. These environments and the infrastructures must be able to support the growing demand for traffic data while also handling distributed IoT data. The arrival of 5G is widely recognized as being able to meet the demands of complex IoT architectures, thus driving further developments in IoT technology. Uh, The introduction of 5G technology marks a revolutionary advancement in wireless communications. 5G user experience rates can reach 100 Mbps to 1 Gbps, which means that user can enjoy faster and smoother network connections. 5G technology supports connection uh, densities of up to 1 million per square kilometer, which means it effectively supports access to massive IoT devices. The service density of 5G technology can reach up to 10 Mbps square meter. To be specific, here is 5G in smart cities. Currently, the concept of smart city is becoming more and more popular, and 5G plays a key role in it. 5G technology's high speed and low latency characteristics provide a solid foundation for real-time data transmission. It enables a variety of smart devices and systems in the smart city to communicate and collaborate with each other more efficiently. 5G mobile communication network is considered as one of the core technologies to realize the smart city paradigm. Using internet technology, smart cities can realize the development of smart grids, transport, healthcare, and smarter education, providing residents with a smarter and more convenient living experience. A smart grid is the primary application of 5G in smart cities. It can help people better detect energy consumption and predict application demand while supporting load balancing and reducing peak power consumption and outages, thus reducing energy costs and enhancing the security and flexibility of grid operations. The introduction of 5G brings new network architectures, which include edge computing and networking slices. Edge computing aims to reduce the latency from the service side to the core network side, provide local closed-loop control, and meet the requirements of low-latency applications. Network slicing enables multi-functionality of a network, allowing the network to be flexibly adapted to different service requirements. The use of the arrival of 5G technology opens up new possibilities for inspections. The use of AR, VR, augmentation technology plays a key role in this process. This type of real-time remote and on-site consultation not only improves detection capability but also shortens the time to diagnosis, allowing for more efficient use of medical resources. In recent years, with the development of technology, 5G and medical AI have been combined in many ways. In emergency care, 5G helps to establish a faster and more stable emergency communication system to ensure close cooperation between all aspects of emergency work. In terms of disease prevention, 5G supports the transmission of large amounts of human health data in real time, assisting healthcare organizations in enabling continuous physical monitoring of the wearer. Uh, and About 5G in telematics in the 5G era, supported by strong network connectivity and guaranteed low latency, the field of connected cars will open up new heights. In the early stage of 5G development, technologies such as CV2X can enable safety warnings, vehicle coupling management efficiency, and partially autonomous driving. Large-scale 5G coverage will facilitate functions such as cooperative vehicle road control, cooperative vehicle driving, and advanced fully autonomous driving. 5G networks rely on technical features such as high transmission, low latency, and high stability to lay the foundation for smart driving network requirements. 5G's low latency characteristic can meet driving requirements. 5G's characteristic of full coverage and massive links can also make driving signals stronger, bring users a better experience than ever before. Uh, with population of 5G technology, smart car system will usher in more innovation and development. In the future, with the further improvement of 5G networks and the continuous evaluation of technology, we can foresee that cars will become truly intelligent vehicles, providing more convenient, safe, and efficient solutions for people's life and traveling. Okay, the last part is about the future of 6G. 6G, which stands for Sixth Generation Mobile Communication System, represents an extension and evolution of 5G system. Though still in the development stage, there are high expectations for its potential. 6G technology will put more emphasis on the characteristics of ultra high speed rate, ultra large capacity, and ultra low latency to meet the higher demand for communication in the future intelligent society. Compared with 5G, 6G will not only be a communication technology, but also an all-round connectivity system that can interconnect everything. Uh, on a technical level, 6G networks will use radio technology and fiber optic networks as the underlying architecture to enhance their high data rate capability. In addition, as people's reliance on the network increases, the security of the communication network has become a crucial issue. Therefore, 6G networks must have the ability to mitigate and defend against network attacks and be able to track the source of attacks to ensure the security and stability of communications. With the advent of the 6G era, the interconnection of everything will become a reality, which will bring about massive amounts of data and information. On one hand, this data involves the privacy of individuals and enterprises, so reliable data protection will be prerequisite for the promotion and application of 6G. On the other hand, real-time processing of this data requires mature edge computing technologies. However, edge computing also faces challenges such as data access limitations and insufficient device computing capability. Therefore, we need to continuously explore and innovate to meet these challenges to ensure the smooth arrival of the 6G era and make greater contributions to the construction of an intelligent information society.